This guide covers PCX module servicing. PCX servicing should be completed in a clean and dry environment, ensuring you take appropriate ESD precaution to avoid damaging any electronic components. First, remove the module from the monitor. Unscrew the inlet heater cap and set it aside. Next, remove the left side panel by removing the 2 countersunk screws from the back and 4 screws from the left side. Remove the right side panel by removing the 4 screws. Remove the central panel by removing the 6 screws holding it to the back plate. There are 2 on the top, 2 on the bottom, and 2 on the front. The top section needs to be lifted up and over the heater. With the module now open, we can begin servicing the internal components. We'll start off by removing the flow sensor on the right side of the module. The flow sensor is held in place by 2 M2.5 screws. Remove these and pull the flow sensor away from the PCB. Rotate the flow sensor down. The barb fittings swivel and will rotate as you do so. Pull the flow sensor off one of the fittings as you rotate, and then the other. With the flow sensor removed, you should now have access to the 3 M3 screws holding the filter manifold on. Remove these 3 screws and their associated washers. On the left side of the module, disconnect the white zero pump tubing and fitting from the zero filter by pushing down on the orange ring of the push fitting and pulling the fitting down. Rotate the sensor and filter manifold assembly out. Unplug the cable going to the PM sensor, pulling the barb out of the 0T. Disconnect the sample pump tubing from the barbed fitting on the back of the filter manifold by pulling the tubing off the fitting. Use a damp cloth or compressed air to clean out the inside of the heater. If using compressed air, ensure adequate safety precautions are taken to avoid breathing in particulate. Next, remove the sensor from the filter block assembly by removing the 2 M2.5 screws and washers. Remove the filter holder from the filter manifold by turning counterclockwise. Remove the filter from the holder and discard. Use compressed air or a damp cloth to clean out the inside of the filter manifold and the filter holder. Do not blow compressed air into the 2 fittings on the back of the filter manifold, as this may rupture the dampening membrane. Again, take adequate safety precautions if using compressed air. Inspect the O-ring of the filter holder and replace if damaged. Once all parts are clean and dry, install a new filter onto the filter holder and screw the filter holder back in fully. Next, install the new PM sensor. Check the PM sensor has 2 O-rings fitted to the lower barb. One should be clear and sit in a groove, and the other should be black and sit loosely along the barb. Insert this barb into the hole on top of the filter manifold. It should slide in smoothly with minimal force. Resecure the new sensor to the filter manifold with the 2 M2.5 screws and washers you removed previously. Check the PM sensor sits parallel to the filter manifold before fully tightening the screw on the left. Test this assembly for leaks by connecting a vacuum gauge to the PM sensor inlet and the vacuum side of a pump to the barb on the front of the filter manifold. Power the pump on. The vacuum should drop to at least -60 kPa if using a pump from an AQS or PCX module. Turn the power to the pump off and check that the vacuum holds. Once you've confirmed the assembly is leak tight, it can now be set aside. Remove the zero pump by removing the 2 M2 countersunk screws from the right-hand side of the module. Disconnect the pump wiring from the PCB, noting the connector and the route the wires run. Lift the pump out and remove the tubing and inlet filter. Reinstall a new filter into the tubing and refit the tubing to the inlet of the new zero pump. Reinstall this pump by reconnecting it to the tubing coming from the solenoid. Ensure the filter and tubing sit behind the solenoid, and resecuring it with 2 M2 screws. Run the wires of the zero pump back through the module and plug them into the same location on the PCB. Next, remove the green zero filter by pressing on the ring of the fitting attached to the solenoid and pulling down on the filter. Replace this filter with the new zero filter, ensuring the arrow on the filter goes in the correct direction away from the pump. Remove the sample pump from the right side of the module by removing the 2 retaining screws. Disconnect the tubing from the sample pump and unplug the pump wiring from the PCB. Service the pump by unscrewing the 4 screws on top of the pump using a T6 screwdriver. Remove the top connection plate. Remove the intermediate plate and replace the valve with a new one from the service kit. Clean the intermediate plate if required. Remove the diaphragm from the pump by unscrewing counterclockwise. There is a shim washer on the shaft of the diaphragm. Tilt the pump to the side to avoid it falling into the pump. Move the shim washer to the new diaphragm and screw the diaphragm back into the pump. Reassemble the pump by refitting the intermediate plate and the connection plate and resecure with 4 screws. Reconnect the tubing from the module to the pump. The right outlet side of the pump should connect to the tubing going to the lure fitting on the bottom of the module. Route the wire of the pump back through the module and resecure it to the backplate using the screws. Plug the pump back into the PCB. Reconnect the sample pump tubing to the back of the filter block assembly. Plug the wire back into the sensor and slot the sensor assembly back into place by reinserting the sensor barb into the T and rotating it such that the assembly sits above the tabs on the bottom of the bracket. Reconnect the zero pump tubing to the zero filter. Secure the filter block back into place using 3 M3 screws and associated washers and spring washers. Next, check the alignment of the sensor in the heater assembly by inserting the alignment tool. If the alignment tool slides in smoothly, then the heater and sensor are well aligned. If the alignment tool doesn't slide in smoothly, then the system needs to be aligned. To align the system, it may need to have a spacer installed on the front of the heater. To install the spacer, unscrew and remove the screw in the front of the heater. You may need to disconnect and bend the LED header out of the way to access it. Next, unscrew the 2 screws holding the heater to the back of the bracket. Do not remove these screws fully, as there are retaining spacers on these screws. Slide the heater up and out of the T, exposing this opening in the heater insulation. Insert the white 3.5mm spacer in this opening. Resecure the heater by reinserting the mounting screws in the back of the heater. Tighten fully and then back off by a 1/4 turn. Reinsert the screw and washers into the front of the heater, ensuring the screw passes through the spacer we added in the previous step. Before fully tightening this screw, ensure the heater is pushed all the way down such that the back screws sit in the bottom of their slot. This sets the distance between the heater and the sensor consistently. Once positioned correctly, fully tighten all 3 screws holding the heater and reconnect the LED plug. Recheck the alignment. If alignment is still not good enough, Loosen the screw holding the front of the PM sensor by inserting a screwdriver through the access hole in the bracket. Loosen the screw a quarter turn and then insert the alignment tool. Retighten the sensor screw and check the alignment again. Reinstall the flow sensor by inserting it into the barb on one side of the filter manifold. Rotate it and insert the other barb in as you rotate. Plug the sensor back into the PCB, ensuring the pins go into the receptacle properly. Resecure the flow sensor to the mounting bracket using two M2.5 screws. Before we reinstall the metalwork, we need to test the module. The first test to do is a leak check. Screw a cap onto the heater and connect a vacuum gauge. Ensure the cap has an O-ring in it or it will leak. Power the module on. The pump should pump down to at least minus 60 kPa. Remove power from the module and monitor the vacuum over the course of a minute. The vacuum should not decrease by more than 10 kPa. If it does, check the module for leaks. The second test is to check and calibrate the flow sensor. Accuracy of the flow measurement is important for transferability of the sensor's calibration to the module. Connect the flow meter to the inlet of the module. Ensure the flow meter is reporting in standard liters per minute and has warmed up so the flow is stable. Connect the PCX module to an EPC. Power the module on. Navigate to the Diagnostics and Advanced page and the Module Settings tab. Set the PCX's flow sensor gain to 1 using the module setting gain for the flow channel in Cloud or Connect. Allow the flow to stabilize and record the reading of the flow meter. Enter this as the new gain for the PCX's flow sensor. Check this gain against the acceptable flow sensor gain criteria located in the servicing instructions. The third test to do is to check all sensors are reporting correctly. Configure the EPC such that PM1, PM2.5, PM4, PM10, TSP, flow, pump speed, and H-temp are all reporting. Wait 2 to 3 minutes for the data to start reporting if using Connect, or 5 minutes for data to appear if using Cloud. Navigate to the Manage Data page and check measurements are reporting for all sensor channels. Check the status bar and confirm there are no channels reporting sensor failed, sensor offline, or sensor due for replacement. In the final test, we want to make sure the PCX module responds to particulate. This is a bump test. First, ensure the module is powered on and is not currently running a zero check. The status LED on the front of the module should be solid green. If it is orange, wait for the zero to complete. Check that you've removed the flow meter and the vacuum gauge from the previous tests. Spray a short burst of test smoke into the air above the PCX module. Do not spray it directly into the inlet. Other sources of smoke and dust, like matches, incense, or sweeping the floor of a dusty room, can also be used for a quick bump test. Monitor the PM readings via Cloud or Connect and ensure they increase following the bump test. Once all testing is complete, you can reassemble the module. Start off by putting the center panel back on the module. Secure it again with 6 screws, 2 top, 2 front, and 2 bottom. Next, secure the left panel using 2 M3 countersunk screws from the back and 4 M3 screws from the side. Secure the right panel using 4 additional M3 screws. Finally, reinstall the heater cap. Now with the module reassembled, you can apply any parameter updates or module setting changes as described in the calibration instructions. If a calibrated PM sensor was installed, be sure to apply any calibration coefficient updates and to record the module's serial number and service date in the calibration certificate.